Hello everyone, and welcome to our series that showcases every single tool in the myCADtools suite. Today we're going to take a look at a tool called BoundingBox. Now, if you've been keeping current with all of your recent additions to SolidWorks, you'll remember that a couple years ago, I think it was 2013, that SolidWorks actually added a BoundingBox feature that you can add directly within SolidWorks. SolidWorks does this basically by taking any part and converting it into a weldment, and then from the weldment cut list, you can create a bounding box. Well, you don't need to go through all that with the BoundingBox in the myCADtools suite. By adding their own version of the BoundingBox, SolidWorks has basically made this tool a little redundant. However, it does offer a little bit more than the standard BoundingBox in SolidWorks. So let's take a look at what the BoundingBox is and what it does. First of all, the BoundingBox allows SolidWorks to automatically create a crude stock model size, select the orientation of your minimum block, and choose the appropriate offsets. So our key features are automatic creation of the gross stock piece, automatic creation of the properties with dimensions X, Y, and Z, and a minimum gross or added allowances. So what that all means is this tool scans your part or assembly and it calculates the minimum amount of rectangular space that your part will occupy. So let's take a look at the BoundingBox in action. Alright, so let's open up this part. We have our standard weldment box in SolidWorks, and as you can see, it's just a structural box with some braces and some I-beam supports on the bottom here. So let's go up and grab our BoundingBox tool in the myCADtool toolbar. What I love about this tool is the simplicity of it. We have some offset options, we have a spot to select a coordinate system, and then on our second tab we have a few different options. Right now the default is set select coordinate system to define the BoundingBox orientation, or you can have the center of mass dictate where you want that BoundingBox to align to. We're going to go ahead and show the minimum box size. This is the smallest amount of space that your part will fit into if you asked it to fit inside of a rectangular box. And down here we can add some properties. We can add properties on a document level or just add to the active configuration. And you can see the property names X, Y, and Z. You can change these if you'd like. You could do left, right, and bottom, but we're just going to stick with X, Y, and Z to keep things simple. And we're going to change this back to select coordinate system to define the BoundingBox orientation. So with that selected, and in fact let's go ahead and leave it on create BoundingBox with respect to center of mass, and then you can see this whole select coordinate system. This is all just grayed out and you can't do anything there. So back in our options we'll be sure to select coordinate system, and then once that coordinate system is live we can just go ahead and grab the coordinate system that I created earlier. And for this basic example I'm going to leave the offset all at 0. So we don't want to offset this box in any direction in any unit of measurement, so we're just going to leave it 0, click OK, and then the tool goes through and basically creates a duplicate of the part and generates a little report. We have minimum box dimensions, X is 800, Y is 1030, and Z is 710 millimeters, and then we have those same numbers here that were inserted at the document level under properties. So when we click OK, we can take a look at our bounding box, and you can see, just go ahead and get it from the side. You can see our bounding box is going all the way around the outside of every single part. Let's take a look from the top. Again, there's nothing on the outside of this box. It's just containing the entire part in its own box. Let's take a look at another side view. So that's our bounding box. So as I said, this tool creates a duplicate of the part. So if we want to go back to our regular part, it's just right here. Nothing has changed. And we can work from this new part. We can save it as, call it weldment box 1, and then that part is saved with the bounding box attached. And then if you do want to suppress the bounding box, you can go ahead and do that. It's just as simple as that. So let's go ahead and take a look at another option. Instead of selection of coordinate system, we can just create it based on the center of mass as mentioned before. And then when I go back to our offset tab, you can see that our selection of coordinate system option is completely grayed out. So that'll be selecting based on the center of mass, and it's going to add these properties and show our minimum box just like before. So let's go ahead and click OK. And we get our report. Our minimum box dimensions, X is 1035.85 millimeters, etc., and these are values inserted into the document properties as well. So let's take a look at this bounding box. You can already tell it's a little off kilter right now. By looking right at the side, you can see that we have a little bit of the profile showing up Let's take a look at the top, and you can really see that this is a little wonky. So we have this corner touching right up here, but then we have some space in between this member and the outside of the bounding box here. And that's the same with every single side. We have a corner here and space down here, corner here, space here, etc. So our weldment box isn't fitting in the bounding box with all of its edges perfectly flush like when we use the coordinate system. And that's because the center of mass for this part is actually a little off center. So let's just go ahead and suppress this and check out our center of mass. Right now it looks pretty good. But when we go ahead and take a look at the side view, you can see that the center of mass is a little high up in the part. It's not directly in the center. And that's actually throwing us off just a little bit. So I just wanted to point out that by using the center of mass to dictate your bounding box, you can come up with a different set of results than you would just by using a coordinate system. The difference in the results may not be large enough to be able to see with your own eyes. So when in doubt, I always suggest using the coordinate system. It's easy just to create one and dictate your X, Y, and Z, and that way you won't get any weird twisting that happens as a result of using a center of mass measurement. So that's the bounding box in the myCADtools suite. Like I said, if you're familiar with the bounding box in the more recent versions of SolidWorks, we do have most of the same functionality. However, there are a few different options that allow you to dial in the results and maybe make it happen a little easier or quicker. So again, that's the bounding box. I hope it's been helpful. If you do have any questions, always feel free to email us at solidworksupport@mlc-cad.com, and we'll see you next time.